Hey guys, how's it going? In this video, I'm going to go through this Leetcode 127 word ladder. And this question was asked by Amazon for 50 times in the past 6 months. So although this question was kind of old, but still popular, and so far it has almost 10,000 likes. Let's dive in. So a transformation sequence from word. The word is called a begin word to the word end word using a dictionary. Word list is a sequence of words. So we go from the beginning word to the first transitioning word. It's called transformed word, and then to the second one and third one all the way to the kth one. And there's some conditions in here. So each adjacent pairs words only change by one single character, right? So for example, when we go from the begin word to the S1, the difference between these two words is only one single letter, and it doesn't matter the position. And Aries SI, so for all the I in, so all these intermediate words that they should be in the word list, and the beginning word is not necessary in the word list. And then the last condition is that the last word SK must equal to the end word. So given two words, the beginning word and also the end word, and also the dictionary that is called the word list, we need to write a function to return the number of words in the shortest transformation sequence from going from the beginning word to the end word if we have to return 0 if such a sequence does not exist. I think it's kind of wordy. Let's dive into some example. I think it make more sense. So for example, if the begin word is hit, and the end word, which is our target, is called cock, right? So the word list, which is a dictionary, right here, is not a Python dictionary per se, but it's called dictionary. Literally, is a dictionary. It is. There are a few different words in here, right? We have a hot, dot, dog, lot, log, and cock, right? Just a reminder, the cock is the end word that we are aiming for, right? So we need to output a function. We need to write a function that outputs 5, and y is 5, and here is an explanation. So this is the shortest path, right, to transit from the beginning word, which is hit, to the end of card. So how can we do that? So we go from hit and then hot, right? So we just only change in this case, we only change the middle character from I to O, and O, the word hot is also happen to be in this dictionary, in this word list, right? And then we go from hot to dot, and from this transformation, we change the first character, right? And then we go from dot to dog, right? From here, we change the last character from T to G, right? And from dog to cock. In here, we change the first character from D to C, right? So this is the complete transformation, and also it takes 5 steps in here, and that's why we output the number 5, and which is the shortest path, right? And this is the first example. Let's look at the second example. The beginning word is hit, right? The end word is cock. So it's the same as the first example for the input. However, in this case, the word list, it is like almost the same, but it does not contain the end word. So that's why there's no way we can go to the end word, right? So for this case, because the word cock is not in the dictionary, it's not in the word list, and therefore there's no valid transformation sequence. This is kind of wordy, but it actually says there's no path for us to go from the beginning word to the end word, right? So that's why we have an output 0. And then we have some constraints in here. For example, the length of the word and also the length of the list. That I suggest you ask those constraints into the interviewer during the beginning of the interview. So, for example, if you are given such a conditions, such a questions, and then I would ask, for example, how long is the word that is possible for the length, for example, and also what's the length of the word list. I mean, so you can get a sense of how scalability of your code is gonna be, right? So and also you can detect lower edge cases, etc. Yeah. So let's dive in to see how can we solve this problem. We will solve this problem use a priority queue. Let's take a look at together. As you can see, the code is not that hard. It is only less than 30 lines of code, but this one's qualified to be it's a hard question, right? Because I think it's pretty tricky and pretty clever kind of solution. So let's dive in to see how can we do that. So first we have first step I would do is to transform the word list, which comes the Python list, to be a word set, because you know when we look up, we have to do most of the operations with the set. The time complexity is only below 1. That's why I think it's gonna we spend a bit of time in the beginning, and we will save some time later in the next operations. So if the end word is not in the word set, that means there's no way to go from the beginning word to the end word. That's why we immediately just access from the function and then return 0. And this is exactly handles the second example here. The end word is not in the word list. Okay, and then we have a queue over here. The queue, we initialize it as just an empty list, and then I use a heap queue, right? And you can use a deck as well. It would do the same thing, but I'm more familiar with heap. That's why I'm going with the approach of heap. So we have a heap queue dot heapify, and just we can transform this Python list to be a heap, and then we do a heap push. So the first element we push it in will be you can see a tuple over here, and the first number, that's the current number of steps, right? At the beginning, we just is the first step. That's why we push the number 1, and also we have the beginning word that we push in as well, right? So this is our initial step. And while the queue is not empty, right? And then we pop off from the queue. And as you can see, this is why we put the end steps at the beginning, and this is our wait, right? And this is where we utilize the priority queue. So the lower the number, we will pop off first, because we're looking for the shortest path, right? We're looking for the shortest path. That's why we just pop this priority queue will pop off the one that has the lowest number in the queue, right? And then we have an exit condition where if the current word that we're looking at that be just being popped off, and that's exactly equal to the end word, right? In that case, we will just stop the entire function, just return the number of steps that we have walked through so far, right? And then we will stop here. Otherwise, we will go through each of the character of the current word, right? And then we will do a replacement of each of the character. So let me explain to you what's going on in these two for loops. So for example, we have the word heat, right? And then we will look through each of the character, use a enumerate, so that we can get the index, also the character that we're looking at as well. So the first one will be, it will be this character, which is in the position 0. So I will be 0. The character will be age, right? And then for all the possible letter, so let's go all the way from A, B, C, D, all the way to E, F, G, all the way to X, Y, Z. This is 26 letters, right? So we can do a replacement for this letter H, right? So it can be placed for the first character will be A, and then B. So if we replace the H by the letter A, so it will be AIT, right? And then it will be BIT, CIT, etc., all the way to ZIT, right? And then the outer for loop over here, we will loop to the next character, which is I, right? So it become H, A, T, and HBT, HCT, HDT, etc. So we loop it through. So we will do a replacement of all these characters by this potential 26 candidates, right? And so now we can search for the next eligible word, I would say. So this is doing the replacement that we talked about, right? So we replace the one character at a time, and then we loop through all the possible positions, right? And then if the next word that's eligible, and what's the eligibility criteria, is in here. If the next word is in the word set, right? And this is why I convert to be a set, because this lookup only takes big O1, right? Versus if this one was a word list, it would take up big O of n, right? This is why I convert to be a set at the very beginning. And then we will do a heap push, right? So if this is word, the next word is eligible, and then we will push it to the heap, right? And then we just use a heap queue dot heap push and push it to the queue, right? So, and then we will increase the number of steps by 1 because we moving forward to the next step. And then also at the same time, we will, push the next eligible word. And at the same time, we don't want to look back, right? So we will remove the next word that we are dealing with away from this word set. So we will not go back to this word ever again later when we in this while loop, right? And that's about it. This is the whole code. And if the entire while loop is finished, but we still couldn't find the M word, then we will just exit from it, right? Return 0. So for time complexity, before I go to talk about the com complexity, and there is a marginal improvement that we talked about in the discussion forum. Let me show it to you. And that is, as you can see, these 26 letters, some of them may not be necessary because some of this character may not be even in the in this word list. So we are only interested in the character that is in the word list, right? So how can we do that? To this for this marginal improvement, it will be like this, right? So we have a letter set. So this is all the potential letter that is in the word list. So as you can see, let's look at it together closely, right? So for all the word in the word list, and then for all the letter in each of the word that we're looking at, and we could push it to this set, right? Let me print it off for you, right? So for example, this is the word list, the hot dog, right? So this is all the character that is within the entire list, right? C, for example, C is right here, and then D is right here, G is right here, H is right here. So we are not necessarily interested in the entire 26 letters. We only interested in this set of potential letters that is, only this letter will be in here, right? For example, we won't be interested in the letter like X, right? Because X is not simple, it's not in here. That's impossible. We have to do the letter X, right? And then we can just replace this letter set like this, right? So we don't need this all the way to 26. We only need this subset of letters. Let's run that. And there you go. So for time complexity, as you can see, this while loop. So this one will loop through all the the worst case scenario will be the big O of number of the word that in the word list, right? So this is this while loop. This is the first. And this heap operation, it will take, this is a binary heap, right? And it will take the log n, right? And log base 2n to be precise, right? And then you have these two for loops over here, and the outer for loop will loop through all the character, right? So and then the inner for loop, it will loop through all the letters, right? All the potential letters, right? So let's say if we are being on the conservative side, we have 26 letters. So it's going to be 26 times the number of characters for each of the word. And this operation is also taking the big O for number of characters as well, right? So if we use L to be number of characters, right? Let me write down over here. L times L times, let's say 26, and then times N, right? So this is going to be the time complexity. And let me explain to you one more time why it goes like this. Because in here, we go through all the letters in the word. That's why we have big OL, right? And then we have to go through all the potential letters for the replacement. This is the 26, okay? And this operation, because the string in most of the programming language is not mutable, so we have to create a new string. And this operation takes up big O of L as well. That's why you are seeing the L square over here. And then this big O of N, that comes from the Q itself, right? Because we have a while loop for the Q. Okay, so this is the time complexity. So for the space, it's going to be big O of N. We need a heap over here. In the worst cases, we have the whole word list will be occupied by this Q. Okay, so this is my solution to this problem. I hope that you find this helpful. If it is, please like and subscribe. Thank you so much for watching. See you next time. Goodbye.